Hi, thank you for trying the Balancing Chemical Equations practice, the PhET simulation. I know that it could have been a little tricky, so this is the video for level 1. If you are having problems with level 1, I am sending you this link first, maybe with some explanation on level 1. You then can proceed on to level 2. But then again, I will try to provide some support if you need it once you reach level 2. So let's take a look at number 1 here. You have carbon plus oxygen producing carbon dioxide gas. And what we want to do is we want to make sure that we have the same number of carbons on both sides and the same number of oxygens on both sides. Remember, this is the reactant side, and the reactant side must equal or must produce the same amount of carbons and oxygens on the product side. So when I look at carbon here on the reactant side, there's one carbon, and on the product side, there's one carbon. Right? When I look at the reactant side over here, I see that I have two oxygens and that I have two oxygens. Everything balances in this first reaction, and you don't have to put the number 1 in, but basically it's saying you needed one carbon for every one carbon. You needed one set of oxygen, which means there's two oxygens here for every one set of oxygen because you have two oxygens here. You never have to use the subscripts of 1, 1, or 1. You can leave them empty because it just implies 1. When we look at practice problem number 2 here, though, you have NO produces nitrogen gas and oxygen gas. And you can see right away that there are two nitrogens and two oxygens on the product side. But you only have one nitrogen and one oxygen on the reactant side. You have to have two on both sides. So the easiest way to do this is to place a coefficient of 2 out front of NO, because that 2 distributes through. It goes 2 times N and 2 times O. So now you have 2 N's, 2 N's, 2 O's, 2 O's. Again, you can put a 1 here and you can put a 1 here, but it's not necessary because it's understood. When you look at equation number 3, you have ammonia, 1 nitrogen and 3 hydrogens producing nitrogen gas and hydrogen gas. And you can see right away that we have an issue because you have 1 nitrogen for every 2 hydrogens. So what I'm going to do is I'm going to multiply this nitrogen over here by 2. By placing a 2 out front, now I have 2 nitrogens and I have 2 nitrogens. But when I put the 2 out front here, that distributes through to the hydrogen. And you already see you have 3 hydrogens, so 2 times 3 is 6. So over here, what do you multiply 2 by to get 6? You know that 2 times 3 is 6, so we put in a coefficient of 3. And my answer here is 2 to 1 to 3. When I look at hydrogen gas plus oxygen gas produces water, you can see that I have 2 hydrogens on the reactant side, and I have 2 hydrogens on the product side. They balance. However, I have 2 oxygens on the reactant side, and I only have 1 oxygen on the product side. They don't match. So what do I multiply 1 by to get 2? Well, again, I'm going to put a coefficient of 2 here. That 2 distributes throughout. So now I see I have 2 oxygens for 2 oxygens. By putting the 2, though, in front as a coefficient, now, though, I've doubled my number of hydrogens. 2 times 2 is 4. So on the reactant side, I must come over here and put in a coefficient of 2. So now I have 4 hydrogens, 2 oxygens, 2 oxygens, and my ratio is 2 to 1 to 2. NO2, nitrogen dioxide, produces nitrogen monoxide and oxygen gas. My nitrogens look to be good. I've got 1 nitrogen and I have 1 nitrogen. But my oxygens, I have 2 oxygens on the reactant side, and here I have 1 plus 2, which is 3. Now, there's no way I can multiply an even number and get an odd number. There's no, so what I have to do here is realize that I have an odd number here, and the only way to get the odd to be even is to double it. So if I have 1 oxygen, if I double it, now 2 times 1 is 2, and 2 plus 2 is 4. So 2 plus 2 is 4. So over here I take the 2 and I have to multiply it by 2 to get 4. So I'm going to put the 2 up front. I've got 4 oxygens. 2 plus 2 is 4. I have 2 nitrogens. I have 2 nitrogens. Now, one thing that we're going to do here as we move into the next unit is off to the side here, we're going to write a ratio, 1 to 1 to 1. We would sometimes answer the question in this format. If I would look at number 2, I would record it as 2 to 1 to 1. For number 3, I would record off to the side as 2 to 1 to 3. And here this is 2 to 1 to 2. And this guy here is 2 to 2 to 1. Let me know if you have any questions over this section. Talk soon.